Hello students, this is Professor Chalai, and in this video we're going to look at significant figures in calculations. Now in our previous video we looked at how we can get significant figures from measuring. We also looked at how we write these significant figures. They represent the uncertainty in the measurement, and how we can read significant figures and how we can round up or not when it's necessary. In this video, we're going to look at how we use those significant figures, those digits, those uncertainties in calculations. And really, there are four basic types of calculations that we need to look at: multiplication and division, addition and subtraction. And we're going to group them together into two categories because really multiplication and division are pretty much the same operator, and addition and subtraction together. So let's look at multiplication and division first. If you're multiplying or dividing two numbers, then all we need to do is look at the number of significant digits. And we look at the lowest number of significant digits, and our answer should have the lowest number of significant digits between our two numbers. There we go. Okay, so let's say you are multiplying 2 by 12. Our answer is 24, right? 12 to is 24. But we need to look at the significant figures in our answer should be the same as the lowest significant figures in the two numbers that we multiplied. So in this example here, this has one significant figure, this has two significant figures. So our answer really should have only one significant figure. So really we should write our answer as 20. This seems weird, but our answer needs to be one significant figure, the lowest number of significant figures. Now, if the 2 was exact, meaning it had, instead of one, infinite number of significant figures, then our lowest number of significant digits would have been 2, which means 24 would have been correct. So if the 2 was exact, then we would have, our answer would be 24. But if the 2 is not exact, but is in fact representation of one significant figure, then our answer should be 20. All right, now let's look at addition and subtraction because those rules are slightly different. So for addition or subtraction, we look at the position of the least significant digit. Significant digit. And we use that in our answer. So let's look at an example of adding now, let's say 20 plus 12. Our answer here is going to be 32, right? But in this example, our least significant digit is in the tens position for this number. Let's use a different color. So it's in the very different color. There we go. It's in the tens positions over here. Here it's in the ones position. So our answer really should be no more precise than our least precise number, in this case, our 20. So our answer should really be equal to 30 because of the position of the least significant digit in 20. It's a little bit easier to think about when we do decimal points. So for example, if we had 1.2 plus 1.43, our answer is 2.63. But for this number here, our least significant digit is in the tens position, so our answer could not have a digit in the hundreds position. So we just round. In this case, we keep it at 2.6 as our answer. Let's look at it a little bit more practically in some examples. You can pause and try this first before you look at my answer, but we're going to do number A, or letter A. So here we have 24.6681 times 2.38 in parentheses plus another number. In math, we do the brackets first. So let's do 24.6681 multiplied by 2.38. That gives us, for the parentheses, it gives us 58.710078 plus 332.58. So I did the parentheses first. Now we need, because we just multiplied, we need to count the significant figures. This has 3. This has more than 3. We don't, so our answer should have 3 because we multiplied and we count the number of significant digits. So 1, 2, 3. We can ignore all of these. We round, but 1 here is less than 5, so we keep the 7. So this is what our answer in parentheses should look like. Now that we have that, we can go ahead and do the adding. So if we add these all together, 58.7 plus 332.58, we get 391.28. But because we added, we need to look at the position of the least significant figure. In here, it's the hundredths place. And in here, it's the tens place. So our answer should only have significant digits up to the tens place because we've added. So we look at the 8. It's more than 5. So we round up. So this means that our answer should actually be 391.3. Let's try B. Pause the video, try B on your own, and you can unpause and we'll go over that together. Okay, so for B, we do again the parentheses first. 85.3 minus 21.489. That gives us, in parentheses, the 63.811 divided by 0.0059. We subtracted, so addition, subtraction, you look at the position of the last significant digit. Tens place here, thousands place here, so our answer should just be up to the tens place. So those are not significant. Now we're dividing. So 63.8 divided by 0.0059, we will have 108, let's write that a little bit nicer, 10813.55932 from my calculator. But we're dividing, so we count the number of significant figures. Here there's 2, here there's 3, so our answers should have 2 significant figures. So 1, 2. So we look at the digit 1 over. It's more than 5, so we need to round up. So we can write 1, 1, 0, 0, 0 to 2 significant figures. Or we could use scientific notation and just write 1.1 by 10 to the 1, 2, 3, 4. Either would be correct because they're both answers to 2 significant figures. So to summarize, there are 2 rules when we're doing math with significant figures. One rule for multiplication and division. You count the number of significant figures and your answer should have the lowest of those. There's a second rule that's different for addition and subtraction. And that in addition and subtraction, you look at the position of the least significant digit and your answer should have its least significant digit in the same position. And if you're doing a problem that involves both addition and multiplication or a combination of all these, you need to keep these 2 rules. You need to use both rules simultaneously sometimes. You can try the other problems for practice, and if you need help with them, just reach out to me on email or come to my office hours and we can go over them together. But that will bring us to the end of this lecture, and I will see you in the next one. Bye.